Let me start by giving a quick overview of the decolonization of math. The point that I would like to make is that decolonizing math is about eliminating the myth, the fraud, and the superstition in formal math. So, you're all familiar with the racist claim of superiority. Whites are superior. And the resistance to that was demonstrated very recently in the George Floyd case, or even more recently in Wisconsin, which sparked anti racism protests. Now, racism persists because of a deep seated cultural claim of superiority. It actually started as a claim of religious superiority, which then went into the claim of color of the skin. Something came later. So, this religious superiority was established in a very peculiar way. Here is a picture of a church built on top of a temple in the middle of Cusco. So the idea was, and it's an extremely crude idea, that if you are able to build a church on top of a temple, you have demonstrated the superiority of Christianity over the Incas. Now, some people would think this is so crude, so it only demonstrates inferiority, not superiority. And there is a very similar related claim of the superiority of Western mathematics. And that claim is critically important for colonialism. As you know, colonialism changed the education system globally. It brought in what was basically a church education system. And the problem of decolonization of math arises from that related claim of superior Western math. I mean, so many superior things, but superior Western math is critical. Math and science. And the idea is there is a relation to racism, direct relation, as is shown in our school text, for example, that this kind of math, this superior kind of math, was first done by a Greek, a white Euclid, or Pythagoras, etc., and that is how they are shown in our textbooks. And the idea is because it is superior, the rest of the world must mimic it, must ape it. Now, the point is that unlike racist prejudices, prejudices in math are not understood. People think mathematics is universal, and they don't understand that there are prejudices in math. I tried to explain the connection between these two claims of racist superiority and the superiority of Western math in two recent newspaper articles. One was in Hindi, and I think they gave me a lot of more space so you can at least see, even if you don't know Hindi, this is in the Jansatta. And the second was in English, it was in the Quint. So I tried to explain how a false history is used to promote racism, and this kind of false history continues to exist in our education system. It continues to inculcate racist values. All right. But the point is, people still don't understand. And they understand that racism is a problem, but they think that decolonization of math, what a silly thing. What is there to decolonize in 1 plus 1 equal to 2? Ha ha ha, they go. So what they have in mind is something like this, what they studied in kindergarten. 1 orange plus 1 orange makes 2 oranges. So simple. What are you talking about decolonization in this? Nothing to decolonize here, is there? But there are complexities, major complexities which people don't understand. So let me start with the first complexity. The first complexity is that the empirical is disallowed in formal math. It is prohibited. And the proof that you just saw of 1 orange and 1 orange is an empirical proof of 1 plus 1 equal to 2. It is a kind of proof which is accepted in normal math, because the proof depends on the senses. You can see the oranges in question. But this kind of a proof is not allowed. It is prohibited in formal math. So that's the first point to remember. And why is it prohibited? You may recall this prohibition of the empirical. Let me give a quick explanation from your school geometry lessons. So in the Indian class 6 text, 6 means K6, it explains what a point is. So what's a point? It says sharpen the tip of your pencil and then make a dot on the piece of paper. And that almost invisible dot will give you an idea of a point. I tried it when I was a kid. I sharpened and I showed it to my teacher. I said, is that a point? No. I sharpened the pencil some more. The point broke. So that is the sort of thing that happens. Because a real point is to be invisible. And these real things have to be invisible like ghosts. If you can see it, it is wrong. That is the principle of formal mathematics. You are not allowed to use anything empirical. And that is an example of invisible points, or an example of how the empirical is prohibited in formal mathematics. But if you can't see it, how do you locate it? The school text says a point determines a location. How do you locate it? It's invisible. A simple doubt. So here are these two guys, and they're quarreling about the location of the point because it's invisible. One says it's here, the other says it's there. How are you going to decide? Can't be decided so easily, can it? So there was this debate on decolonization of math and science in South Africa. You can see the video of it here, and it's a fairly longish video, and it is from 2017. So just take a look at the URL, and I won't go into that. But I explained this point about invisible points, and then I laughed. What is this silly thing? People believe in invisible points. The racists, white racists, got enraged. They are laughing at them. I should feel humiliated. I should feel angry. I should not laugh at this foolishness. So a racist newspaper news reporter tried to rebut me. So what did he do? He could not explain. How could he explain how to locate an invisible point? Can't be done. So he gave proof by authority. He just cited the authority of some unknown mathematician. Oh, it is a very common thing. You routinely handle invisible points. Okay, if you routinely handle, explain it. He could not explain it. But he said it and he was convinced. So I hope you're getting the drift. Prohibiting the empirical, you can't see the point, it forces you to rely on authority. And the question then is, which authority? The authority of that guy or my authority, for example? So you have to rely on superior authority. So you've reduced mathematics to a matter of authority, and which authority is superior. And then, of course, white racist, white Western authority is superior, as so many defenders of colonial math, Western math, like Wikipedia will say. Wikipedia will always say reliable sources are only Western sources. And it is exactly like, believing that the king is wearing beautiful clothes, invisible clothes, right? So he imagines that this is what he's seeing, but of course, the reality is something different. So that, I think, explains the connection between decolonization and anti-racist protests, that we are really talking about superior authority. And both reject the claims of Western superiority, which originate from religious prejudices. Let me again emphasize that I won't go into it. So here is an example of, this is a book on the Bible defense of slavery. As you can see, it ranks the people and so on, and it claims the authority of the Bible, superior authority of the Bible, to prove that the Negroes and the Red Indians are inferior. And I won't go into it, but I just want to point out that these are claims which have been based on religion, and this book went into its 5th edition just before the declaration of so-called emancipation. So a key part of the struggle to decolonize math is to restore the simplicity of the empirical proof of 1 plus 1 equal to 2. The same empirical proof that you saw earlier, this simple thing about using the empirical. And to explain, because people have this fear, oh, if you change it, something will happen, there will be a tremendous catastrophe, that restoring normal math does not affect any practical application of math. Not at the level of 1 plus 1 equal to 2, not at the level of rocket trajectories. And just think about it. I won't go into all the arguments here, but prohibition of empirical were to give us something superior. Why not prohibit the empirical also in science? Now let's see how you do it in formal math, 1 plus 1 equal to 2. So formal math or Western math or colonial math demands an axiomatic proof of 1 plus 1 equal to 2. All right. What's an axiomatic proof? So use Peano's axioms. In this debate that took place in South Africa, that is what the mathematician said. Use Peano's axioms. Right? I've already shown you the video of that. And this is taking too long. Yeah, it's the same thing. So that is what he said. But he was wrong. He was wrong because I was, it's not so simple. In formal math, colonial math, one can mean several different things. That's the second complexity. What exactly does one mean? One could be a natural number, which is not the same as an integer. One as an integer, which is not the same as one as a rational number, which is not the same as one as a real number, so-called real number, nothing real about it, like invisible points. So the point is, these different notions of one are similar in some senses, but they are definitely not identical. So the Cape Town mathematician wrongly assumed that by one I meant the real number, the natural number 1. But actually I meant the real number 1. I wanted a proof of 1 plus 1 equal to 2 in real numbers. Now he didn't know what to do, because you can't use Peano's axioms with real numbers. You have to do something else. But why real numbers? Let me explain quickly, because it was about science. Science needs calculus, and according to what we teach in the university today, calculus supposedly needs real numbers. So if you want to be able to do science, you want to be able to do calculus, you should be able to prove 1 plus 1 equal to 2 in real numbers. On that current textbook understanding of calculus, I don't say that calculus necessarily has to be done like that, but that's the current textbook understanding. But this creates a problem. The moment you bring in real numbers, say in 2015, I gave a talk at MIT, and here's a video of that. And you can see the link, and you can just watch that video. You can watch the video because I'm talking about visual proof. I asked about real numbers there. And all smart students there, and also many people who were quite old. Nobody could define a real number. And that's why I'm pointing to the video. Please check. Check the video. Nobody was willing to stand up and say, yes, we understand what real numbers are. Now, if so many smart people are not quite sure what a real number is, then how can they prove 1 plus 1 equal to 2 in real numbers? So those students were actually smart of MIT and Harvard. Why? Because at least they knew what they did not know. That's my definition of an expert. One who knows what he does not know. It's not possible to know everything in the world, but at least you understand what you don't know. And the problem only arises from people who think, oh, what is there in 1 plus 1 equal to 2? Nothing. So they think the notion of formal real number is easy. It is not. So you first of all need to understand the complexity. So formal real numbers are typically defined using something called Dedekind cuts or equivalence classes of Cauchy sequences. I've taught this sort of thing for several years at the university, at the postgraduate level, because you don't do these things typically at the undergraduate level, maybe at the advanced undergraduate level. The problem is that in order to do this, it requires extensive use of set theory. Now, there's a third problem the moment you bring in set theory, which is set theory, the metaphysics of infinity. So, what do you mean? So, these equivalence classes, for example, of Cauchy sequences, they are hugely infinite sets, each of whose elements is also an infinite set. So, it's a metaphysics of infinity that we are talking about. And although set theory is taught practically with mother's milk as some sort of very simple Venn diagrams, that is nonsense. It creates all sorts of paradoxes. For example, Russell's paradox. I won't go into complex issues like Banach-Tarski paradox. You have simple thing like Russell's paradox. And Cantorian set theory had that problem, or naive set theory had that problem, that it could not resolve the paradoxes which were resolved by axiomatic set theory. So what does that paradox mean? It means that you have a contradiction, and if you have a contradiction, you will end up talking complete nonsense. So you're not sure. And it took some, the fact that it was resolved or thought to have been resolved in the 20th century doesn't really mean anything. So anyway, if you want to prove 1 plus 1 equal to 2 in formal real numbers, you at least need to know axiomatic set theory. And most people don't know that. And most people cannot even define a set in axiomatic set theory. I recall I was having a discussion with a head of a mathematics department of an IIT, which are prestigious institutions in India, and he had been teaching there for 40 years in Bombay IIT, and then he came somewhere else, and I asked him, can you even define a set? And he said, set is a collection of objects. What is this nonsense? What is meant by collection? What is meant by objects? You cannot do axiomatic set theory in this manner. All right. So I won't belabor the point. The point is that people don't know, and if you don't know, what can you do? You can only proceed on faith, on mere trust in the validity of set theory, which is required even for 1 plus 1 equal to 2. To negate this reliance on faith, I demand that all those required results to prove 1 plus 1 equal to 2 must be derived from first principles. You must understand what you are doing. And I want it to be done in the manner in which Bertrand Russell proved 1 plus 1 equal to 2 in cardinals, not in real numbers, much simpler. But still, for that he needed 378 pages. Now here is the 378 page. Does it make the slightest bit of sense to you? What is this rubbish? And 378 pages of such rubbish. And you say 1 plus 1 equal to 2, there is nothing to decolonize. This is only in integers, cardinals. I want to do it in formal real numbers with set theory. So I hope you are getting the idea of what the problem is. And here is the formal challenge, which I call the Cape Town challenge. Prove 1 plus 1 equal to 2 in formal real numbers, not integers, not natural numbers. Prove it from first principles in the manner of this 378-page proof, writing out everything explicitly, all the proofs, no abbreviation, no assumption. Don't assume any result of axiomatic set theory, whatever result you need. You're only doing 1 plus 1 equal to 2. Why should you have trust and faith and this and like invisible points and so on? You don't want all that. You want everything spelled out explicitly. Nobody has met the challenge. And my guess is that it will take at least about 1,000 pages or so. I guess I have to see it. So the moral of the story is that colonialism has made math difficult. So difficult that most people can't manage 1 plus 1 equal to 2. Colonialism, it's colonial math because colonialism brought in formal math. It did not have this sort of nonsense beforehand, making 1 plus 1 equal to 2 enormously difficult, even for professional mathematicians, like that head of the mathematics department in IIT. The second point is that although you have made it so very difficult, 1 plus 1 equal to 2, nothing of practical value has been added. It is not an iota. That proof that Bertrand Russell gave, does it add anything in a grocer's shop? Of course not. It makes it very complicated. He can't do a simple calculation, and as you can see, the chap is getting very annoyed. He's already given him a bump on the head. Okay, but it does not also add in rocket technology. Let's be very clear about it. People have this superstition, oh, it must be doing something. No, formal math doesn't do anything. But real numbers are deemed essential for the calculus. So although they are deemed essential, let's elaborate on that case of rocket technology. The trajectories of rockets are calculated using computers, and a computer cannot represent a real number. All right? It works with a finite set of numbers called floating point numbers. And computers cannot do that sort of metaphysics. Human beings think they can. So you can take a look at this Hawaii paper of mine. This is a 20-year-old paper, and this is in the Philosophy East and West. 51, number 3, 2001, pages 325 to 362. You can also get this on my website, ckraju.net/papers. Most of the stuff is there. And here is the abstract of how formal mathematics is diverse from the empirical. Right? So, the third model, that prohibiting the empirical forces reliance on authority of a particular Western metaphysics of infinity. It's another matter that it is tied to church dogmas of eternity. I have a separate paper on that. I won't go into those details. But the point is, this is declared superior, superior, superior on the strength of Western authority. You've not gained anything in practical value. You make things terribly complicated. It's a superior. Nobody understands it. It's a superior, superior, superior. So, the critical issue is that this kind of reasoning, metaphysical reasoning or reasoning without facts, was a technique invented by the church and glorified by the church as part of Christian rational theology, which was set up during the Crusades and modified and appropriated from Islamic rational theology in order to contest with the Muslims and convert them. So this is the situation of complexity without practical value that decolonization of mathematics seeks to correct. So you finish off the complexity, it makes math easy. You actually enhance practical value when you make math easy, because otherwise you can't do difficult problems. And it rejects the dependence. That's the critical part which bites people. Rejects the claim of superiority, rejects the dependence on Western authority to decide what is right and wrong in math. And that's what really bites. That's what, because there is that hidden racism there, that we are superior and what we are giving you is what you have to do. All right. So let's examine it now. What's the justification? The justification for the claim that Western mathematics is superior. The justification for the claim that deductive proofs or axiomatic proofs are superior. So the claim is that how are they superior? Not in practical terms, epistemically superior. Why? Because they are certain, they are infallible, or at least less fallible compared to empirical proofs. But is this true? The justification, it has been believed for long. Is it true, or is it just a superstition? So let's first see how the case for epistemic superiority is established. The first part, the claim, the way it is established, is that Greeks first did this superior mathematics. Okay. Now, the fact is that Egyptians built pyramids accurately, huge pyramids. You saw that case of the Inca. They also working with huge blocks of stone. Now the claim is, the Western claim is, the claim of superiority is they may have built, but they were inferior because they did not know the Pythagorean theorem. Heath says it, Gilling says it, Needham says it, Claggett says it, and so on. All right. Supposing we take that claim that they did not know and the Greeks knew. All right. So where did the Greeks do it? Where can we find it? The related theorem is found, certainly not with Pythagoras. That's complete myth, Pythagoras and the Pythagorean theorem. But okay, some related theorem is found in so-called Euclid's elements, which comes from the 10th century approximately. All right, long after that. But anyway, you find some theorem. Okay. And should also remember that this book was used as a church text since about the 13th century. All right. So it is found. Now, the claim of Greek origins is fraud. Claim of Greek origins of axiomatic proofs. First of all, proofs are found also in other cultures. For example, there is this Indian proof, which I have explained in that Hawaii paper. But you see, it involves moving things around in space. You cut this triangle, move it around, and then show that these squares are equal. So it's an empirical proof. Involves an empirical proof. All right. But the point is that there are no axiomatic proofs in Euclid's elements. It's just plain fraud. People say, okay, it must be there. There's a book, read it. But you read the book, read even the first proposition. So the first proposition is a very simple thing. You must have seen this figure that you draw one arc like this and draw another arc, and where they intersect, you join. And the first proposition is about building an equilateral triangle on a given line segment. But the thing is, this is an empirical proof because you see the two arcs intersecting, but there is no axiom from which that intersection can be deduced. So there are no, in fact, not even the first proposition, nor the second last proposition, or the last proposition, which is the Pythagorean proposition. There is no axiomatic proof of it in Euclid. Complete fraud that Greeks did something axiomatic. Complete fraud. All right. And this fact has been publicly admitted since 20th century. Historians like Needham don't take it into account. It has been admitted. Formal math started with David Hilbert. His Foundations of Geometry, which was in 1898. Why did he write that? Because he wanted to rewrite Euclid, the book, to provide the axiomatic proofs missing in it. That is formal mathematics, what Hilbert did, not what Euclid did. And the fact that you need something different is already a clear admission that there are no such proofs found in Greek tradition. Of course, Hilbert's geometry does great violence to the original. For example, it is synthetic. It's called synthetic. Why? Because length measurement is not allowed in Hilbert's geometry. So why don't we go tell this to kids or to their parents that we are going to teach a geometry, very superior geometry, in which no measurement of length is allowed? No. It should at least be clear. So people don't quite understand, and that's how they do it. All right. So once that fraud is exposed, you don't expect that the church will give up so easily, or even that the people who are indoctrinated by it will give up so easily. So now what would be the claim? Claim that people like Russell would make? All right, Euclid made an error, but he intended pure deductive truth. He didn't have any in his book, but he intended to have them. You don't, how do you know exactly his intentions? And just matter of simple common sense. How were they so agreeable to the church if he was there, existed 1500 years earlier? How did he write something so agreeable? The church burned so many books, but it adopted this book as a church text. Common sense. So you have to read the book. How will you judge the intentions? And a simple thing, and if you recollect your school geometry, you had diagrams, and the book has diagrams. And as Russell will note, diagrams have nothing to do with formal mathematics. But diagrams have something to do with another kind of Greek mathematics described by Plato, for example, in the Phaedo. So let's just check out the Phaedo and let's look at the diagram. Here we are. So it says if you put a question to a person in a right way, he will give you the right answer. The point is that mathematics is something innate knowledge. That's what Plato is trying to say. It is knowledge of the soul. And that right reasoning is already in him. And this is most clearly shown when you take a person to a diagram of anything of that sort, because it arouses the soul. This is Plato, Phaedo, and as you can see, it is in classics.mit.edu. Just search for Phaedo and you will get it, Plato. All right. So it has diagrams. So therefore, the natural conclusion would be that it is about that kind of Platonic or Neoplatonic geometry. It's about mathesis. It's about arousal of the soul, as Plato said. But no, it was his intention, and he made an error. In giving diagrams, he made so many errors. So, in fact, his intention was quite different, and the point is the church has a reason to hide it because the notion of soul used in Plato was later cursed by the church. There was this big, huge quarrel, described it in 11 Pictures of Time. But the commentator, Proclu, commentator on Euclid's Elements, confirms that this is the purpose of that book, that mathematics in that sense arouses the soul and hence leads to a blessed life. The whole case of Western case of Greek origins of formal math, axiomatic math is built on one single forged remark, contrary to everything that is stated in Proclu's book. But you have to believe it because it's authority and Western authority is superior, so you must believe it. Do we know anything else about Euclid to judge his intentions? No. No evidence for any Euclid. So, about 10 years ago, I had a challenge prize of USD 3,000 to provide primary evidence for Euclid. There's a video of that also. It is there on my YouTube channel, Goodbye Euclid, where I offered this prize in front of the Deputy Education Minister of Malaysia. It's standing for 10 years, no evidence, no primary evidence. And if you eliminate that, see, the point is, if you're talking about Greeks and so on, it seems we are talking about, we are actually talking about the church. You eliminate the Euclid part, it becomes clear that it's the church philosophy which has been imposed. And what is that church philosophy? It's reason minus facts. There's no such intention. But that was the church intention because facts are fatal to the church. So it's willing to accept reasoning, but not reasoning with facts, reasoning without facts. That's the essence of formal mathematics. That's the essence of church reasoning. And that's the connection between the two. And that is why it is declared superior and that's why it's glorified. So now, can we check why are axiomatic proofs supposedly superior? Is it just a superstition? So let's start with the first step. Empirical proofs are fallible. Yes, everybody agrees. Everybody agrees. In India, it's agreed. In science, it is agreed. And all systems of Indian philosophy agree that it is fallible, but nevertheless, they accept the empirical as the first means of proof, as does science. Accept error, there may be experimental error, but you repeat the experiment if there is experimental error, there is a doubt. And you correct it inductively. If there is an error, whether it's a snake or a rope, you just poke it with a stick and decide. It's not very difficult to decide. So the fact that it is erroneous, may run into error, is not a big problem. Everything can run into error. But the claim that it's infallible, that is problem. That is a superstition, like the belief that the Pope is infallible. The moment you come across things like infallible, human beings are innately fallible. So you say axiomatic proofs are infallible. Now I have taught mathematics and lots of students used to flunk in math. They flunk all around the world. Why? Because they turn in erroneous proofs. So that is fallible. You cut their marks. If it is infallible, everybody should get 100% in math all the time. So it's not quite like that. There are errors. So which deductive proofs are infallible? It's not the case that all deductive proofs. Okay? So which deductive proofs are infallible? All right. So let's say maybe an authority gives a proof, like Russell. It's a long and complex proof, 378 pages. It could have errors. How do you know? How can you be certain you're talking about infallibility? Not even a typo in those 378 pages. Did you check? Of course not. Even if you check 100 times, there might still be an error. You might miss out some error. So it is just a matter of faith that it is infallible. And there are many erroneous proofs have been published. For example, the Riemann hypothesis by Kosambi, most lately by Atiyah at the Royal Society. So, simple example is that all Western scholars believed for 7 centuries that Euclid was the model of deductive proofs. They were all wrong, even about its very first proposition. So, the belief that it is a model of infallible proof is just a matter of faith, and this faith has proved to be wrong even when it was held by all Western scholars for 7 centuries. It was wrong in the very first proposition, which is not a very complicated proposition. I showed that to you. Okay, let's take some more examples. Chess is a game of pure deduction, but every human being, the biggest grandmaster, almost always makes an error, hence loses to a computer. It's a simple thing, check it out. Ask the grandmaster to play, and they lose. So the fact is, why do they make an error? Because the mind is more fallible than the senses. Senses may make an error, mind makes an error very easily. So how do you check? If there are errors, how do you check an error in the deductive proof? You can only check it inductively. You check it once, check it twice, check it 3 times, and so on. No other way to do it. Therefore, deduction is more fallible than empirical proof or induction. A complete falsehood, idiocy in Western philosophy that, induction, deduction is infallible. It's certainly more fallible because it relies on induction, it relies on authority, right? It relies on induction, relies on authority. As such, it is much more fallible than empirical proofs. And there are many more arguments can be given them in so many papers. The point is, formal mathematics is not epistemically superior. This is just something which can only be established by means of fraudulent claims that Greeks did this, Greeks did that, by means of myths that this was Euclid's intention, and so on, by means of superstition that deductive proofs are infallible and such like. All right? That's the point I want to make. And decolonization of math is about correcting this. Okay, by eliminating the fraud, by eliminating the myth, by eliminating the superstition in math, which superstition creeps into science. So if you decolonize math, you also decolonize science. Now, the interesting thing is the Western response to this, because colonialism changed our education system. It was based on the key premise, the West is superior in math and science. Everybody accepted that. That's not true. Decolonization of math destroys that premise. And since that premise is destroyed, Western philosophers, Western scholars, Western mathematicians have only responded politically, not philosophically. They don't have any argument, they know that. But they will just go on talking, asserting their authority, oh, it is like this. Why don't they come out openly and debate? They refuse to engage with either the arguments or the evidence. They don't have evidence for Euclid, they don't have evidence, they don't have evidence for superiority, but they are comfortably situated and they want to maintain that. And they want to maintain their power. That's the state of affairs, and that's what decolonization of math is about.